Thanks, Spencer. I'd like to thank Nugget for inviting me here to Berlin. I, of course, am quite jet-lagged. I live in Chicago. I've been to Germany a number of times. I had never been to Berlin, and so yesterday I got in around 11 a.m. I thought I'd just power through the day and see as much of the Berlin as I could. In fact, I wasn't able to do that. I had to nap for 2 hours, but then I got out, got on a bike, rode around for about 4 or 5 hours, and had a fabulous time. You really have a remarkable city here, and I am disappointed that I had just gotten to Berlin now. And I'm going home tonight, unfortunately. I wish I had another couple of days, but so is life. So as I said, it is 2 a.m. my time in Chicago, so if I start losing it or going off track or being rather incoherent, someone can come up and throw some water on me or slap me. I mean, it's totally fair. So it'd probably do me some good. So a little bit about myself. I was an engineer coming out of university in the tech boom in San Francisco, whatever it was, 14 years ago. And eventually kind of switched careers. I ended up writing about technology at Forbes magazine for about 7 years, and more recently I just left Forbes. I have a startup of my own. Went through, maybe some of you have heard of Y Combinator. I came out of Y Combinator last year with my two buddies who are my co-founders, but I also wrote my second book, which is Automate This. And writing a book, you know, it's very serious. So it's what serious people do. They write books. Very serious people. And when you go out and write books, how do I make this go forward here? There we go. So it's like I said, it's very serious. So when you want to write a book, you have to go out and talk to serious people, of course. And I have serious friends who do serious things, and so I went out and had lunch with a number of them. And originally, my book was going to be about Wall Street, and that was what I was covering at Forbes magazine at the time, the kind of the algorithmic takeover of our markets. And literally 70% of all the trades in the United States are made by algorithms that are informed by these vast mountains of data. Perhaps that the progress on that front of data informing a industry, certainly in terms of money involved, is more advanced on Wall Street than anywhere else. But so I went to talk to some of these very serious people. Serious person right there. And I went out to lunch with one of my friends who's a serious guy. He manages an investment firm, and he is a professor at the Kellogg School of Business Management at Northwestern University, which is in my hometown. And we're at lunch, and I'm telling him about this book, and he says, "Oh, this sounds fine. It's very serious, but you know what? The story and the word he used, the quantification of Wall Street, is really part of a bigger story. It's about the quantification of everything." And I said, "Well, this is quantification of everything. This is pretty serious. This is a good idea." So as I went and researched Wall Street and talked to all these serious people, I kept running into these people who had peeled off from Wall Street and taken the methods or the science that they developed in order to make all these trades and these vast stores of data on Wall Street and gone into other fields. And it turns out a lot of the science is applicable everywhere. I mean, literally. And just for instance, some of you have probably heard of Renaissance Technologies. This is the most successful hedge fund in the history of the world. It's on Long Island outside of New York, and all it is big data. That's all it is. And the founder is an MIT mathematician, PhD from MIT, and he's of course very important, and the other two guys are very important scientists who are now the co-CEOs, who he hired from IBM. And these two guys were the first ones who created these algorithms that would translate German to English, English to French, French to German, but that did it very well. They didn't sit down. Normally, in the past, when people wrote algorithms to translate two languages, it'd be someone who knew both languages and knew most of the rules associated with both, and would sit down and try and write code to conform to all those rules. But as we know, this is not a linear thing, translating German to English. It's not that simple. And so what these two guys did is they took the Parliament records for Canada, because Canada has two official languages, French and English. And they just random both sets of these millions of words through machine learning algorithms. And in fact, they produced the beginnings of the algorithms that we now use to translate everything. That they're not perfect, but they work very, very well. And that same science went on to earn Renaissance Technologies billions and billions of dollars. So in Renaissance, like everybody else seemingly in technology these days, likes to talk about one word more than others. It seems like it's all about algorithms. I think when you hear about a new startup, or when we talk about Google, or whoever it is, you're always like, oh, how does Google know that this is what I'm looking for? And people are like, oh, it's an algorithm. It's just an algorithm, don't worry about it. So I mean, what is an algorithm? I mean, we almost talk about them like we all know, and I'm not sure that everybody knows the definition. I mean, really, it's just a set of instructions that a machine or a human can carry out. It means you give the set of instructions an input, it produces an output. For instance, when I was a sophomore year engineering student at university, one of the first algorithms I had to write was a tic-tac-toe algorithm. And the input, of course, is the move of the human. The output is the move of the computer. And this is a fairly simple algorithm to write. Of course, for someone starting out, it seemed like a very complicated problem. But now, of course, algorithms are these incredibly complicated things where there can be literally millions of nodes, and you put in an input, and of course, then it calls a data table, brings this piece of data, puts it in a math equation, drops in another equation, and all of a sudden, you get an output that says, buy Apple stock, whatever it is. But they've grown so complicated that, in fact, they're invading everything. They can do everything. When I say, oh, come on, everything, they can't do everything. I mean, you know, authors tend to be prone to hyperbole when putting subtitles on their books, but they really are invading everything, and they can be dynamic. They can learn. Algorithms can change. They can evolve. And as I said, they're taking over everything. Well, what do I mean everything? I mean everything. Music, scouting for major league sports teams, dating, grading essays, flying planes, driving cars, reading legal documents. I mean everything. We are at a colossal fork in the arc of humanity. And you know, I'd be remiss not to mention, by the way, that the original hacker in my book is a guy named the name of Gottfried Leibniz, who of course was a German, and he's the one who conceived of the binary computer language more than 300 years ago. So interesting to be here. But what he did, in addition to coming up with the binary way of computing, was he conceived of labeling men by the words that they choose to say. And not by how they say it, but by exactly looking at the words. He thought that there was this binary process of examining all of our personalities by the words that we say. And of course, he never got to put that into action. He never wrote algorithms to do this. But in fact, that is what there are scientists doing now, that exact thing. And so as I said, algorithms can do all of these things. And again, creating original art, grading students' essays, making crucial national security decisions, reading human personalities, like Leibniz theorized on more than 300 years ago. Algorithms are already doing this. They're figuring out our strengths, our personal weaknesses. And they do this with the knack of a world-class psychologist. So to describe just how vast algorithms take over of humanity may become, I'm going to concentrate on this last example of the psychology reading bots, because we only have a little bit of time here, so I'll spend my time on this story. This story goes back to NASA in the 1960s. And NASA, at the time, was starting to think about putting scientists into outer space, in addition to its normal set of astronauts. And before this, astronauts had always come from the ranks of the United States Air Force. They were test pilots. These were men who strapped themselves into airplanes that went, that broke the sound barrier, that spied on the Russians, that went to the edge of the stratosphere, and that often crashed at any moment. I mean, these guys were wired for danger, and they didn't flinch when it came to it. So they made for perfect astronauts. NASA was never worried about any of these guys doing the wrong thing in space. They never worried about them getting so scared about dying that they wouldn't do what had to be done to perhaps get themselves home or get NASA out of this jam. But scientists, there's no Air Force test pilot program for scientists. How do we know what scientists are going to hold up when a hatch starts leaking or the module isn't releasing from the rocket or whatever it is? How do we know which scientists are going to be able to work together with differing personalities 200 miles up over Earth? So NASA set out to create this system of personality classification. And I might mention that the Russians, NASA knew, had had several space missions compromised by crew conflict. So these were people who went up and things went very, very bad. NASA was sure, in fact, that the Russians had at least one space homicide that we never heard about. They wanted to avoid all these things. So NASA set off to create this quantifiable personality classification system. It would be a predictive system that could foresee conflicts between people and know who would crack in a bad situation and who, in the midst of a space disaster, would shut their emotions down and do what had to be done. So NASA started working on this in the 1960s. And over the years, with a lot of Air Force psychologists, they developed a program that was right in tagging people about 50% of the time. So better than you could do than just sitting down and guessing. But still, it was wrong half of the time. And then NASA, as they often did, they invited a visiting psychologist in to look at their evaluations and evaluate some of the new candidates with them. And this guy's name was Tabby Kaler. He was a psychologist from Purdue University. And during the interviews with astronaut candidates, the NASA psychologist would sit there and scribble down notes for hours and hours as they just fired questions at these people. And then when they were done, they'd go back to their office and look at their other candidates, the other data they had, and make the call as to how they thought this person would end up performing as a potential astronaut. Now, the visiting professor, Tabby Kaler, would sit there for 10 minutes, write things down, and then he'd put his pencil down, and he was done. And he never picked it up again. And 2 years later, when they were able to go back and look at the accuracy of the psychological evaluations, because they knew how people had performed at this point and knew who had shaken out in the astronaut program, it turned out that Tabby Kaler was right almost every single time. And the NASA psychologists, as usual, were wrong half of the time. So how can this be? And so they went back to Tabby Kaler and said, well, hey, we want to build our system around whatever it is you're doing. And so that's what they did. With his help, they created the most powerful and the fastest psychology machine in the world. The agency used this in everything they did. And of course, you've even heard about it, but they didn't want anybody to know about it until recently. And so how did they do it? How did the system work? Where his Tabby Kaler system works by keying off the words that we speak, just like Gottfried Leibniz theorized so long ago. The way in which we structure our sentences, the words we choose, the pronouns we choose, the verbs we choose, the way we invoke first, second, or third person all says a lot about our personality. And it takes years for a person to figure out how to be the type of diagnostician necessary to wield this science as a human. But of course, the words that we say, they're data. It's data that can be organized, parsed, and stored. Once speech recognition software, and it's the same type of software that those two guys from Renaissance Technologies worked on, once that got to a point where it was relatively dependable, it figures that some company would make the connection of NASA's personality parsing bots, and NASA's personality parsing science, and the bots that could, in fact, utilize this. So, but who and what type of application could do this? I mean, certainly you're not going to build a web app and spend 10 years building a web app. That doesn't really work. You can't spend that type of money to build a web app and have people come use it for 13 bucks a pop, right? I mean, you're never going to get your money back. And you're not going to sell software to psychologists. They're not going to buy software that's going to put them out of business. So who would build NASA's real thing? Well, it turns out that there is something that we all do each and every day, a lot of us do, where a personality parsing bot is in fact quite useful. Customer service. When we call a customer service line and we hear that message, this call may be recorded or listened to for quality assurance purposes, I think we're all assuming, well, at some point maybe they do record this thing. And when this customer service person goes in for their annual job review, it says to them, the boss can listen to a call and say, you did a good job with this part and this part and this part, but you could do better here. All right, we'll see you later, thanks. But in fact, when you hear that message, this call may be recorded or listened to for quality purposes. In a lot of cases, it means that you've invited 6 million algorithms in for a listen. And in fact, that's exactly what they're doing. And so how do they work? Well, when you call up one of these large companies, and the ones that employ these bots, they will take note of your phone number and then route you to a random customer service agent. And the customer service agent handles your call, blah, blah, blah. But the whole time, the algorithms are listening very, very closely. And within 2 minutes into the conversation, they know they've put you against one of 6 personality types and made a bunch of other notes on you. So the next time you call up, it sees the same phone number again, the algorithms do, and now this time, it routes you to a customer service agent with the exact same personality like yourself. And so what does that mean? Well, the company behind all of this, a Chicago company called Mattersight, ran a study on thousands of customer service calls to Vodafone over a number of years. And as it turns out, when you call customer service and you get an agent who is not like yourself, your call lasts about 10 minutes, and it comes to a happy conclusion for both the company and the person about 47% of the time. When you call the same company and you get a customer service agent with a personality much like yourself, the calls are 5 minutes long, so they're half as long, and they result in a happy conclusion 90% of the time. And that's because when you reach someone much like yourself, they understand what it is you want, the type of resolution you want, and they get you there very, very quickly. You instantly have empathy for the other person's situation because they're just like you. Some people want to be coddled. They want to be told, we're sorry we screwed this up, blah, blah, blah. Some people call and they just want a resolution as fast as possible. And so when you get the same type of person, it saves that company a lot of money if they can get you to the right type of person every single time. AT&T in the United States has more than 1 million people who work customer service. By putting in this type of software, they can save $1 billion a year because their operations, their customer service operations, are a $4 billion operation. So this is a very big deal. There's a warehouse in Minnesota the size of a soccer pitch that stores all of these conversations. Mattersight, the company we're talking about, has listened to more than 1 billion conversations now. They spent $60 million over 10 years to build these 6 million algorithms. And every time you call, of course, the data center in Minneapolis is looking for that last little piece of data that is kept on ice that matches your brain exactly. And so if we can do this with algorithms and data, if we can figure out what it is you want and who exactly you are by the words that you speak, what is it that we can't do? And just speaking of this type of technology, the technology that was originally developed at NASA to decode our brain, okay, so it helps in customer service, but where else is it going to go? Well, I mean, now Mattersight is talking about putting this into a piece of software that would read all of its employees' emails. Not because it's looking for people doing bad things, but let's say you are a large company with a sales organization, and you might have a very large client that maybe pays you $1 billion a year, whatever it is. Your relationship with that company might be 300 people deep. And a lot of times, the C-suite, the executives, don't know that that relationship is going sour until it's too late. You've lost the sale. A competitor took them away. Well, what if an algorithm was looking at all times at people down the chain, and it could see when things started to go bad, when the communications lines started to break down, and it could easily do this. And the people at the top were alerted, and they could fix the relationship before the sale was ever lost. I mean, that sounds good and it sounds bad, of course, but I don't think there's any doubt that we're going to see this. This is going to happen within the next 5 years. Your emails are going, at a big company, are going to be read. They're going to be read for customer service efficacy. They're going to be read for sales efficacy, all these things. And I think we have reached the end of utility on Wall Street when it comes to employing algorithms that use data as their input. Just as we saw on May 6, 2010, when the American markets lost $1 trillion in less than 5 minutes, and to this day, nobody has any idea why. And then again, on August 1st of this year, Knight Capital, a company most people have never heard of, lost $440 million in 40 minutes. And by the way, Knight Capital is one of the oldest, most practiced hands of putting algorithms and data into use in our markets. They had an algorithm that completely ran out of control on them. So I think Wall Street, whereas data and automation did do a lot for us during the 1990s and into the 2000s, it's now possible, of course, to sit down at your computer in your kitchen and trade a stock for $7. That's nice. You know, that democratized the markets to some degree. But we have hit the line of utility. And just as drawing that line in the sand between utility and being a menace has been very hard for Wall Street, been very hard for the people who work there, it's been very hard for the regulators. I think in the coming years, quants, programmers, people in advertising, people all over are going to bump into that line. And it's up to them to figure out, is this the end of utility? Pushing past this, am I going to be a menace? And just as you or some of your colleagues may hit that line of utility, the line between being useful and being a menace, I think I've hit my line of utility up here. So in the name of not being a menace, I'm going to wrap it up. Thank you for listening.